What up? Here's your section 10.2 and 10.2 video. We're choosing between counting methods. Now I introduced these counting methods, but we need to learn what techniques I can use to actually choose between them, because the math here is not hard. It's choosing the method which is hard. So let's take a look at one of the most logically tight memes I've ever found. I just love it. Just read it. It's great. And it helps us to remember how to choose between these four different things. Okay, so remember we had four different methods, okay? We had the combination, we had the special permutation, the fundamental counting principle. So I want to summarize these quickly for you and just give you some pointers to look for so that you know which method to use when. So first of all, the combination, we know that the formula is NCR, and that's n factorial over r factorial, n minus r factorial. Okay, and remember the combination is when a new order doesn't create a new possibility. So when a new order does not create a new possibility, in other words, order doesn't matter. Okay, next, what we can have is we can have a special permutation. Remember the formula looked a little complicated. There was an n, and then there was like n sub 1, n sub 2, ... And it was n factorial over n1 factorial, n2 factorial, etc. And each of those n factorials on the bottom represented things that repeated. So the special permutation is when I'm arranging, but there are repeats. So arranging, but with repeats. Now, for the last two, because these are two pretty specific things, right? A new order doesn't create a new possibility, and arranging with repeats, everything else is either a permutation or a fundamental counting principle. And I know permutation had that fancy formula, but basically what it comes down to is slots. And you're just multiplying everything together. So if it's not one of these first two possibilities, you can pretty much just do it with slots, and I'll show you what that means. So, summary done. Let's move into actually looking at problems. I have 4 problems. There's going to be one of each, and I'm going to try to talk to you about how to choose which method. So, first of all, a license plate has 3 letters, A through Z, and 4 digits, 0 through 9. How many plates are possible? Now, in order to understand what's going here, I'm going to actually make an example license plate, because actually seeing a possibility can really help you understand the math, okay? So if I'm making an example license plate, let's see, I need 3 letters. I'll do my initials, SRG. I need 4 digits, so I'll just do the year of my birth, 1991. This is a possible license plate, right? So here's what I like to do. In order to see if it is a combination, I need to see if rearranging one of these results in a new possibility. Because if it does, it's not a combination, because remember, combination order matters. So in other words, what I'm saying is, if I say change the place of the G and the R, maybe I change the place of one of the numbers too. Does this look like a new license plate? Like everything's the same except the order is different. And is this a new license plate? And the answer is yes. This is definitely a new license plate, which means that this is definitely not a combination problem, because remember, combinations, the order isn't supposed to matter. Furthermore, is it a special permutation? Am I like rearranging things and like I have repeats? Like I know I have repeats here, but did I have to have those 9s? I didn't. I could have had an 8. Now there are no repeats. So the point is, like I can have repeats, but it's not like I'm rearranging things with repeats. So also not a special permutation, which means it's either a permutation or a fundamental counting principle. It actually happens to be a fundamental counting principle. Permutation has to do with rearranging, and since I'm not really rearranging here, it's just a straight up fundamental counting principle. So I'm going to choose my slots. I have 7 slots total. I have my first 3 slots representing the letters. There are 26 possible letters, so each of these has 26, 26, 26. And then there are actually 10 digits. 0 through 9 happens to be 10. If you think it's 9, just remember you're also adding that little 0 in. 1 to 9 would be 9 digits. 0 through 9 is 10 digits. If I multiply all of these things together, let me do that real quick. I get 175760000. Whew, that's a lot of possible license plates, which is why they use this many letters in my home state of Pennsylvania, because these are all the different license plates you can have. You're never going to get a duplicate here. They can just keep making more and more. Okay, next problem. You are choosing 4 books to read this summer out of a total list of 20. How many different sets of books can you read? Okay, so I'm looking for different sets of books. Now, let's just list a possible set. I'm choosing 4 books, so I'm really into the young adult fiction. Maybe I'll choose Twilight. Maybe I'll choose Divergent. Maybe I'll choose, I don't know, other of these books. Twilight 2, and maybe I'll choose, I don't know, Harry Potter 6. Okay, so there are my 4 books. Now the question is, if I change the order of 2 of these books, does it make a new set? So if I change the order, if I put Divergent up here and put Twilight down there, does that make a new set? Well, no, it doesn't. It's the same 4 books, it's just, yeah. So basically, it's a combination, right? Order doesn't matter. Because if I change 2 books, it's the same set. So this is a combination. I don't even have to worry about the other 3. It's definitely not then, because order doesn't matter here. I can change the order of the books. It's the same set. And this is 20, because I have 20 books. Choosing 4. This is going to be 20 factorial over 4 factorial, 20 minus 4 factorial. And let's simplify some things. I'll talk about how this looks all simplified out. Now remember, this 20 is 20 times 19 times 18 times 17 times 16 times 15 times 14, and on down. But at the bottom, because of this 16 factorial, which is 16 times 15 times 14, and on down, all of these things are going to cancel. Now I also have the 4 factorial, so 4 times 3 times 2 times 1. This isn't going to factor, but if I'm clever, I can cancel some things like this and this cancel, this and this can cancel. Now the 9 and the 3 can cancel. And so really all I'm doing is 5 times 19 times 3 times 17. I can cancel some things. I only have 4,845 sets of books, because order doesn't matter. A third example, in how many different arrangements could you read 4 books out of a set of 20? So now that I have the word arrangements here, it definitely does matter. Am I going to read Twilight first and then Divergent? Or am I going to read Divergent first and then Twilight? That's a different arrangement. Arrangement means order definitely does matter. Order definitely does matter. And since order matters, I definitely don't have a combination. I don't see any repeats in here. Like, it's not saying that 2 of the 20 books are the same. So this is also not a special permutation. And because I am doing arrangements, remember, these 2 I can kind of do the same way. But because I'm doing arrangements, this happens to especially be a permutation. So you can either use the special formula for permutations. 20p4 is 20 factorial over 20 minus 4 factorial. So let me just show you how this will work out. Just like the previous one, this is going to be 20 times 19 times 18 times 17 times 16 and on down. But then this 16 factorial is also going to be 16 times 15 and on down. So all these cancel, and I'm left with just 20 times 19 times 18 times 17. And that leaves me with 116,280. These are arrangements of books. So notice how many more arrangements there are than sets, and that is because sets order doesn't matter. Here order does matter. Now what you could also do is you could also do this in the style of the fundamental counting principle or fundamental counting method. There would be 4 slots since you're choosing 4 books. For my first book, I have 20. For my second book, I would have 19 because I already chose one book. For my third book, I'd have 18 because I already chose the first two books. And for the fourth book, I would have 17 because I already chose the first three books. And notice that's exactly the same as this. All right, one last one. I know the video is getting long. I'm sorry. I'm going as fast as I can. How many different ways are there to arrange the letters in the word algebra? So definitely making this switch, switching the L and the A results in a new arrangement, which means that it's not a combination. And look, A, it's a repeating letter. So this is definitely a special permutation. So remember, the way I set up the formula, the way I'm going to write it is how many letters total? 1, 2, 3, 4, 5, 6, 7. I know that the A's are repeating, and there are 2 of them, so I'll put a little 2 down here. And I don't think any of the other letters are repeating. So actually, it'll just be this. And remember, the way I calculate it is 7 factorial over 2 factorial. And we have room for extra factorials here if they were written here, but they're not. So 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial, 2 times 1. These last two cancel. So let's put this into my calculator real quick. And there are 2,520 different ways of arranging the word algebra. So quick summary, combination, try switching 2 of the things in your order. If it makes a difference, it's not a combination. Special permutation, look for repeats. And remember, permutation and fundamental counting principle are essentially the same. Permutation is specifically an arrangement, but you should be able to calculate both of these using the same method. Thanks for watching.